3. Listen closely. The reality you experience every single day, the chair you are sitting on, the light filling your room, the screen you are watching this on, might just be a thin, very fragile film floating on the surface of something infinitely deeper. I want you to imagine looking out at the ocean. You see the waves, the sea foam, the reflection of the sun. But you know that beneath that surface lies an entirely different world, a vast abyss teeming with invisible life, crushing pressures, and unexplored depths. What if our universe, everything we have ever seen, touched, or loved, is just the surface of the cosmic ocean? For decades, we physicists have suspected exactly this. But now, deep underground at the Large Hadron Collider at Cern, something extraordinary is happening. We are smashing protons together at velocities so incredibly close to the speed of light that time itself slows down. And in the microscopic wreckage of those violent collisions, we are not just finding the building blocks of our own reality. We are finding missing pieces. Energy is quite literally disappearing. It is vanishing from our instruments without a trace. Where is it going? The physics points to a staggering, brain-breaking conclusion that missing energy might be bleeding over into a hidden universe. We call it the dark sector. It could be a shadow realm, completely intertwined with our own, occupying the exact same physical space as you and me right now, but entirely invisible to our senses. We may have just recorded the first definitive whisper from a parallel reality. If you are ready to peel back the illusion of the everyday world, and if you want to understand the true, terrifying, and beautiful nature of existence, take a moment to subscribe, because we are about to step into the dark sector, and what we find there will permanently change how you see absolutely everything. 3. To truly grasp the magnitude of what we are seeing in the data right now, we first have to ground ourselves in how we understand the physical world. 3. I want you to think back to a time when you were younger, perhaps sitting at a workbench or a kitchen table. Maybe you took apart an old mechanical pocket watch or a heavy vintage radio. 3. You unscrewed the back plate. You pulled away the casing. Inside, you found a breathtakingly complex architecture of interlocking gears, taut springs, copper wires, and vacuum tubes. 3. By pulling that machine apart, by laying every individual piece out on the table, you could understand how the whole system functioned. The movement of the second hand was no longer a mystery. It was the inevitable result of the gears pushing against each other. This is the exact same philosophy that has driven physics for the last 100 years. We look at the universe, the stars, the trees, our own bodies, and we want to know how the clockwork ticks. But we cannot just unscrew the back of an atom. The pieces are too small, and they are bound together by forces of incomprehensible strength. 3. To see the gears of reality, we have to use brute force. We have to smash the watch against the wall and take pictures of the springs flying out. That is exactly what we do at the Large Hadron Collider. 3. Deep beneath the idyllic countryside, on the border of France and Switzerland, buried in a circular tunnel 1227 kilometers around, we have built the most complex machine in human history. We take protons, the dense little hearts of atoms, and we fire them in opposite directions. 3. We use massive superconducting magnets to accelerate these particles until they are traveling at 99,999% the speed of light. Then we cross their paths. 3. They collide at the violence that is almost impossible to picture. For a fleeting fraction of a second, in a space millions of times smaller than a grain of sand, the temperature spikes to more than 100,000 times hotter than the center of the sun. It is a microscopic recreation of the Big Bang itself. In that intense concentration of energy, the protons melt away and the fundamental gears of reality pop into existence. Over decades of doing this, we have painstakingly identified all the pieces on the table. 3. We call it the Standard Model of Particle Physics. It includes quarks, electrons, neutrinos, and the famous Higgs boson. For a long time, we physicists were incredibly proud of ourselves. 3. We thought we had mapped every single gear in the cosmic watch. We thought our inventory of reality was complete, but science is governed by an ironclad law, a bedrock principle that you already intuitively understand. Think about balancing a physical checkbook at the end of the month. You sit down with a pencil, your receipts, and your bank statement. 3. It is a closed system. Every single penny must be accounted for. If you start the month with $2,000 and you can only find receipts for $1,500 and your bank account is empty, you do not just shrug your shoulders. You know with absolute certainty that $500 is missing. The money did not simply cease to exist, it went somewhere. 3. It was spent, or it was lost, or it was stolen. In physics, this is the law of conservation of energy. Energy cannot be created out of nothing, and it cannot be destroyed into nothing. It can only change forms. 3. This means that the massive amount of energy we pump into those protons before they collide must exactly equal the mass and energy of all the debris that flies out of the collision. 3. The cosmic ledger must balance perfectly down to the very last decimal point every single time. For a long time, the ledger balanced perfectly, but as our technology improved, as our sensors became unimaginably precise, we started looking closer at the margins. We would smash these particles together. 3. The computers would furiously calculate the energy of all the resulting sparks and fragments, and a cold chill began to run down our collective spines. The numbers did not match. 3. Energy was missing from the ledger. It was not a rounding error. It was not a glitch in the software. It was a glaring, undeniable deficit in the bookkeeping of the universe. To a physicist, a missing energy is a siren blaring in the dark. It tells us that our inventory is incomplete. There is a thief in the room. Something invisible is carrying that energy away from the crash site, and that realization forces us to ask a terrifying question. If energy is leaking out of our known universe, what kind of world is catching it? When you realize energy has vanished from your experimental ledger, your first instinct as a physicist is not to jump to wild exotic theories. You do not immediately scream parallel universes. You assume there is a mundane, overlooked explanation. You assume a ghost you already know has slipped past your security guards. In particle physics, we have had those ghosts for decades. We call them neutrinos. Neutrinos are real subatomic particles created in radioactive decays and in the heart of our sun. Trillions of them are flying through your fingernail every single second, passing straight through the planet Earth as if it were empty air without hitting a single atom. They carry energy, and they are notoriously hard to catch. 3. When we built the detectors at the Large Hadron Collider, 4 massive multi-story instruments like ATLAS and CMS, wrapped in millions of channels of high-precision silicon and scintillating crystal, we designed them specifically to account for neutrinos. We can calculate the exact shape of their invisible departure. So when energy began disappearing in these new high-energy runs, we checked the neutrino signatures first. We crunched the numbers. We ran the algorithms over millions of collisions. The missing energy was not moving like a neutrino. The momentum conservation and angle of the missing mass and the frequency of these events did not match anything in our textbooks. It was not an elusive guest we had seen before. It was an absolute stranger. 3. To understand why this is so deeply unsettling, you have to ask yourself a fundamental question that most people take for granted. Why can you see anything at all? Hey, why can you see the wall in front of you, the road beneath your car, or the stars in the night sky? You see things because light, which is an oscillation of the electromagnetic field made up of particles called photons, bounces off matter and strikes the cells in the back of your eyes. When you touch a table, you feel it resisting your hand, not because the atoms are solid little billiard balls, but because the electrons in your hand are electrostatically repelling the electrons in the tabletop. 3. The electromagnetic force is the entire language of your sensory reality. It is the language of vision, touch, chemistry, biology, and everyday matter. 3. Every particle in the standard textbook of physics speaks this language, or at least talks to the particles that do. Now I want you to perform a simple thought experiment with me. 3. Imagine a completely different family of particles. Imagine a set of particles that has mass, that has structure, that moves and interacts, but does not speak the electromagnetic language at all. 3. It does not emit light, it does not reflect light, it does not absorb light, and its electrons, if it has them, feel no electrical repulsion toward the atoms making up your hand. 3. If such a particle were sitting right in front of your face right now, you would not see it. You would not feel it. If it drifted towards you, it would glide right through your skin, through your bones, right through the center of the earth, completely unaware of your existence, just as you are completely unaware of its presence. This is what we call the dark sector. For nearly a century, we have looked out into the cosmos with our telescopes and realized that ordinary matter, everything made of atoms, the stars, the planets, the nebulae, and all of human civilization, accounts for only 5% of the mass and energy of the universe. Roughly 27% is something we call dark matter. We know it is there because its gravity pulls on galaxies, 3, keeping them from tearing themselves apart. But we have always assumed it was a simple, boring dust, a single, cold, inert particle drifting silently in the cosmic void. 3, what the data at Cern is beginning to whisper is something far more profound and far more complex. What if dark matter is not just one lonely, inert particle? What if dark matter is an entire ecosystem? 3, what if there are dark protons, dark electrons, dark neutrons held together by dark forces, forming dark atoms, dark chemistry, and dark structures? An entire hidden universe casting no shadow, emitting no light, coexisting within the exact same coordinates of space-time that we inhabit. But if this hidden universe is completely blind to our forces, how could we possibly detect it? 3, how could energy leak from our world into theirs? There must be a doorway, a microscopic gateway, where our reality and theirs briefly touch. In physics, we call it a portal. 3, and that brings us directly to the heart of the paradox. Here lies the great paradox that keeps theoretical physicists awake at night. If this hidden realm is truly isolated, 3, if it does not feel our electromagnetism or our nuclear forces, then by definition, it should be entirely impossible for us to ever make contact with it. If two worlds share no common language, 3, they can never have a conversation. Yet, we are seeing energy leave our collision chambers. Think about that contradiction. If the dark sector has zero interaction with our matter, 3, energy could never cross the boundary. But if it does interact with our matter, why has it remained hidden from every telescope, every microscope, 3, and every laboratory experiment for the past 300 years of modern science? Why do you not feel it walking down the street? Why does a dark planet not crash into our sun? 3, how can something be both completely untouchable and yet demonstrably connected to our reality? To solve this paradox, you have to picture two grand, sprawling houses built right against each other, 3, separated by a massive soundproof stone wall. In one house, you have our standard universe. The inhabitants live their lives, turn on the lights, cook dinner, listen to music. In the adjacent house, 3, you have the dark sector. Its inhabitants have their own lights, their own music, their own entirely different way of existing, because the wall between them is so thick and impenetrable. 3, both families live for generations believing they are the only house on the block. For the wall to be breached, there must be a flaw in the masonry. There must be a tiny conduit, a microscopic keyhole, or a single vibrating copper pipe running through the stone that connects both rooms. In the language of modern quantum field theory, we call this a portal, free. And we believe we may have found the key that fits the lock. That key is a particle I have spent much of my professional life studying and marveling at, the Higgs boson. In 2012, when we first discovered the Higgs boson at Cern, the world celebrated because it explained how fundamental particles acquire their mass. But the Higgs has a unique, almost bizarre, property that sets it apart from almost every other particle in the universe. It has a quantum spin of 0, and it carries no electric charge. Because of this unique neutrality, the mathematics of quantum mechanics tells us something astonishing. The Higgs boson is mathematically permitted to couple, to talk, to particles outside the standard model. It does not need an electric charge to communicate. It can act as a cosmic translator. It can bridge the chasm, free. Imagine two people who speak completely different languages and cannot understand a single word the other is saying. But then, a third person enters the room who happens to be fluent in both tongues, free. That mediator is the Higgs field. In our particle collisions at Cern, when we pump enormous energy into a microscopic point, we generate Higgs bosons in abundance. And for a fleeting instant, for a fraction of a septillionth of a second, an ordinary Higgs boson might transform. It can decay not into ordinary quarks or electrons, but into particles of the dark sector. When it does that, 3, the energy simply slips through the keyhole. It walks out of our house and straight into the house next door. There is another equally fascinating possibility, what we call kinetic mixing 3. Imagine you have 2 identical tuning forks. You strike one, and even though you never touch the second one, it begins to hum, because the vibrations travel through the air between them. 3, we suspect that our ordinary photon, the particle of light, might have a shadowy twin in the dark sector, a dark photon. Under extraordinary conditions, the quantum fields can oscillate together. 3, allowing a photon from our reality to briefly transform into a dark photon and vanish into the shadows. This resolves the paradox, but it replaces it with a far more haunting question. 3, if there is a doorway, and if energy can slip through it, what is happening on the other side? What kind of structures are being built in that neighboring room? 3, and what does it mean for the ultimate fate of everything we know? Now, I want you to prepare yourself, because we are about to push this logic to its absolute breaking point. 3, I want to take you to the frontier where intuition completely shatters and the true strangeness of reality comes into view. When you hear the phrase hidden universe or parallel world, 3, what is the picture that forms in your mind? Most people instinctively picture something billions of light years away across vast cosmic gulfs of empty space free, or they imagine science fiction concepts of alternate timelines splitting off into the infinite void. We naturally assume that to reach another world free, you must travel an astronomical distance across time and space. That assumption is based on an illusion of human perception. What if the other universe is not far away at all free? What if it is less than a millimeter away from your skin right now? To understand how this is physically possible, we have to talk about something that has captivated my entire professional life. Wait, the geometry of extra dimensions. I want you to imagine a simple thought experiment. Picture an ant crawling across a giant sheet of paper. To that ant, the world has only 2 dimensions, free forward and backward, left and right. The concept of up and down is not just unknown to the ant, it is completely inconceivable. It has no words for it, no senses to detect it free, and no physical apparatus to move into it. Now, imagine I place a second sheet of paper just an inch directly above the first sheet. On that second sheet, another ant is living its life, crawling around, free searching for food. The 2 ants might be separated by a tiny physical distance in 3-dimensional space. If you measured from one ant to the other with a ruler in the 3rd dimension free, they are an inch apart. Yet, as far as their 2-dimensional senses are concerned, they might as well be on opposite ends of infinity. They can scream as loud as they want free. They can shine 2-dimensional flashlights across their sheet of paper, and the other ant will never perceive a single flicker or sound. In string theory and modern theoretical physics, we describe this exact architecture using a concept called brain-world cosmology. Our entire universe, the vast cosmos containing 2 trillion galaxies, and every star you have ever seen may be nothing more than a 3-dimensional membrane, a brain floating inside a higher dimensional space that we call the bulk. And another brain, another 3-dimensional universe with its own distinct laws of physics and its own version of matter, could be hovering right next to ours in a 4th spatial dimension. Why do we not fall off our sheet of paper? Why can we not simply look up into that extra dimension? Because the particles that make up your body, the electrons, the quarks, the photons of light bouncing into your eyes are like open strings whose ends are physically tied to our brain. We are trapped on our sheet of paper by the very forces of nature. Light cannot travel into the extra dimension. It is glued to our surface. When you sit in your living room, you think you are looking at empty air. But if brain-world cosmology is correct, you could be sharing that exact same space with an entirely different cosmos. If you reach your hand out into the room right now, You might be reaching directly through the heart of an alien dark star, or sweeping your fingers through the core of an entire dark galaxy. You do not feel it. You do not see it, because your matter and their matter are locked to different sheets of paper, separated by an infinitesimal gap in a dimension you cannot point to with your finger. The only things that can leap across that cosmic gap are the particles that are not glued down. 3. Gravity can cross the gap, which is why we feel the pull of dark matter throughout the cosmos. And at the microscopic scale, in the violent blinding temperatures of the Large Hadron Collider, we are shaking the very fabric of our membrane so hard that energy is rattling free and jumping the gap into the bulk. Think about what this truly means. 3. We are not just isolated creatures on a tiny blue rock drifting through an empty, silent void. We may be living in the middle of a crowded cosmic apartment building, completely blind to the neighbors living on the other side of a microscopic wall. And this brings us to the hard, unavoidable truth that physics must now confront. Here is the hard truth that every physicist and every thinking human being must eventually face. For centuries, we operated under a comforting, unspoken assumption. We believed that the human mind, armed with mathematics and observation, was destined to comprehend the totality of existence. We thought the universe was an open book, written in the language of geometry and calculus, waiting patiently for us to turn the pages. We looked at the night sky, and we believed that what we saw was what existed. We built telescopes, we split the atom, we mapped the cosmic microwave background, and with each monumental discovery, our confidence grew. We genuinely believed we were approaching the final chapter. We dreamed of a theory of everything, a single elegant equation that you could write on a t-shirt describing all matter, all forces, and all of time. 3. The data emerging from Cern and our modern cosmological surveys shatters that dream into a million pieces. The hard truth is this: our universe is not centered around us. 3. It is not even primarily composed of us. Everything you have ever known, every star that shines in the heavens, every planet, every ocean, every living creature that has ever walked this earth. 3. Every drop of blood, every thought, and every breath is made of ordinary matter, and that entire category of reality constitutes less than 5% of the cosmos. We are not the main event. 3. We are a rare, tiny minority. We are the cosmic foam floating on top of a vast, dark oceanic reality that we cannot see, cannot touch, and can barely detect. 3. Imagine living in a magnificent mansion with hundreds of rooms, grand libraries, towering ballrooms, and intricate gardens, but you have spent your entire life locked inside a single broom closet. 3. You measured the dimensions of the closet. You studied the wood grain on the door. You cataloged every dust particle floating in the air. 3. And you proudly declared to yourself that you had discovered the fundamental architecture of the world. That broom closet is our 5%. That broom closet is our standard physics. 3. We must also confront a deeply humbling biological reality. Our brains and our sensory organs did not evolve to perceive the deep structure of the cosmos. Wait, human biology evolved on the African savanna to perform very specific practical tasks: finding food, avoiding predators, throwing a spear, and surviving long enough to pass on our genes. Wait, our senses were tuned by natural selection to interact solely with the electromagnetic forces of our local environment. Wait. We see a narrow sliver of the electromagnetic spectrum because that is where the sun emits light. We feel the solidity of the ground because our feet need to push off the earth to walk. Wait. We are prisoners of our evolutionary heritage, looking through a keyhole at a reality that spans across dimensions and hidden sectors. And this creates a profound scientific crisis. If 95% of the mass and energy in the cosmos belongs to the dark sector and dark energy, wait. And if entire parallel structures exist on neighboring membranes just a millimeter away in a higher dimension, how do we ever write a complete theory of everything? Wait. If our physics only describes the rules of our local broom closet, then the laws of nature we hold so dear may simply be local bylaws, not universal truths. For many people, wait, this realization feels terrifying. It feels cold. It makes us seem insignificant, small, and hopelessly blind. It strips away the comforting illusion that reality was built for our eyes. Wait. But I see it in a completely different light. To me, this is the most exhilarating moment in the history of human thought. The fact that a species of ape bound to the surface of a small rocky planet, using tools made of silicon, copper, and glass, can look into the microscopic debris of a proton collision and deduce the existence of a hidden universe is nothing short of miraculous. We are not at the end of physics. We are at the very beginning. We are standing on the threshold of a doorway that has been locked since the dawn of time, and we have just felt the first breeze blowing from the other side, which leads us directly to the final breathtaking question. What happens when we finally push that door completely open? 3. When we finally turn the handle and push that door completely open, the consequences for human civilization will be so profound that they will divide our history into a before and an after. 3. What happens when we finally step through that doorway and learn to map and perhaps interact with the hidden universe? To understand the absolute magnitude of this impending shift, 3, we have to look backward. I want you to imagine living in the middle of the 19th century. The world was lit by whale oil lamps, heated by coal, and bound by the physical limits of horse-drawn carriages and steam trains. At that exact same time, a few brilliant, eccentric individuals, like Michael Faraday and James Clerk Maxwell, began playing with invisible, intangible things. They experimented with bits of lodestone, spinning copper coils, and invisible magnetic fields. To the average person walking down those cobblestone streets, these experiments were nothing more than academic parlor tricks. 3. How could an invisible force that makes a compass needle twitch possibly matter to everyday life? But those invisible forces were electromagnetism, and once we understood how to harness them, it changed the trajectory of our species permanently. We electrified the planet. We built radio, television, global communication networks, and the internet. Every piece of modern medical technology, every satellite in orbit, and the very device you are using to hear my voice right now was born because we dared to master an invisible realm that our ancestors could not see or touch. Now, I want you to scale that up by a factor of unimaginable proportions. Right now, we are mastering the physics of our 5% reality. We are like 19th century engineers marveling at a steam engine. But if we can map the dark sector, if we can understand the physics of a realm that contains 5 times more mass than our entire visible universe, we are not just adding a new chapter to a textbook. We are handing humanity the keys to the master architecture of reality. Imagine the technological implications. 3. If we learn to manipulate particles that do not interact with ordinary electromagnetic matter, we could potentially transmit information straight through the solid body of the planet Earth without a single cable or satellite. We could engineer new physics, creating structures or mechanisms built from the dark sector itself. Or perhaps we could tap into reservoirs of cosmic energy that dwarf the nuclear furnaces of the stars. If brand-world cosmology is correct, and we learn how to manipulate the boundaries of our own membrane, the very concepts of spatial distance and gravity might become tools in our hands rather than absolute barriers holding us back. But beyond the technology, the deepest, most permanent shift will be in who we are as a species. For all of human history, we have been trapped in the dark, running our hands along the walls of our microscopic fraction of reality, thinking we understood the shape of the room. By pushing this door open, we elevate ourselves. We step out of the broom closet and into the infinite towering mansion of the true cosmos. We become the universe finally waking up to its own unfathomable vastness. Exploring these depths requires more than just giant underground machines and complex mathematics. It requires a dedicated community of minds willing to look past the superficial noise of the everyday world and stare directly into the profound mysteries of existence. If you are captivated by this journey, if you value these deep dives in the absolute bleeding edge of human knowledge, I invite you to support our ongoing exploration. Beneath this video, you will find a tool called Super Thanks. It is a direct, powerful way for you to help me continue translating the most complex, mind-breaking discoveries of modern physics into a shared journey we can all experience together. Your support ensures that we keep pushing the boundaries, keep asking the terrifying questions, and keep bringing the light of understanding into the darkest, most beautiful corners of the cosmos.